I'll start with a quick review for this book, The Art of Statistics. I was debating, so the book started very well with very interesting ideas and what can statistics do. But I feel maybe after the third or the half of the book, it started to get a little more technical, highly technical, I would say, with actual formulas and numbers. And I was listening to it that doesn't help. But even if I were to read it, it's not what I'm looking for. The art of statistics could be done with not diving so deep. And if you do dive deep, try to simplify it. I felt like it's more of taking a statistic class, advanced statistic class, which I did not wanted to take. So I don't think he did a very good job at presenting, at least the second half of the book, at presenting this information to the wide public, which is, I would say, this is the intention of the book. The Art of Statistics, how to learn from data. That's why I was like debating between a 2 to a 3. I think I'm more likely to give it a 2 eventually, because it was just kind of I lost some part of it. It was just like not for me. It's like I'm not interested to dive in that deep, and I just lost the point. So I think you could do a better job at presenting this information to the public. Let's see some of the notes I was taking. Negative and positive percentages can be misleading. 99% versus 1% doesn't tell the whole story. It could be different ways of presenting information, but that doesn't tell what actually happens. 99% sounds like a lot, but first of all, 1% could be a lot too, or the other way. You say 1% is positive or something like that. You could present that information in a better or worse way. The average is often confused between mean to median. When you say average, what does it mean? The mean or the median? There is a confusion about it. The wording of the survey can significantly alter the result. The way they ask the question could make much difference on the result, which is widely known. But every time I hear it, every time I read about it, it sheds some light on what's going on, which is like, sorry, many of those surveys are not very well made. And the results follow, obviously. Standard deviation is the measurements of distribution. How far is it? Educated people are more likely to have brain tumors, but this is probably because they are more likely to be diagnosed. So it comes with this idea that they had research, and they came out with the idea that educated people who have degrees, are more likely to have brain tumors, and they started to have all kinds of speculations and theories. But what's happening is that it's more likely to happen because they're more likely to be diagnosed in the first place. Educated people maybe have more money, or for whatever other reason, maybe they're more educated, and therefore they're more likely to be diagnosed. Interesting idea. Lower rate of accidents after speed cameras are installed could be attributed to regression to the mean. So sometimes after they install speed cameras, there is a decrease in speeding. But this is not necessarily because of the speed camera. What can happen is regression to the mean, which is if there is ups and downs, eventually things would not be way too high or way too low. Calibration in weather prediction would make sure that 70% chance is indeed correct. That's calibration. To check that if it actually 70% is actually 70% and not 70% chance happen 100% of the time. You know what I mean by that is like 70% is 100%. So that's the calibration, which they use in all kinds of other areas. Algorithms that are too complicated are not very useful because they take too much things into account and they don't do a good job eventually. The size of the sample is very important for its accuracy. Sampling the sample can give us a clue about it. Therefore, the idea here is that the size of the sample is very important, because the bigger the sample, the more accurate it is. Therefore, there is this idea of sampling the sample, and that's when you know better what's going on. The gambler's fallacy is thinking that one side of the coin is due while it's all individual flips. That's the gambler's fallacy. Let's say we flip a coin 10 times and it's tails all the time. People feel that heads is due, even though it's just another flip a coin and the coin doesn't care. The null hypothesis is what we're going to work with until we have a contradiction. That's the null hypothesis. We have A. Until we disprove an A, we're working with A. Side note, the book is often overly technical and feels like a textbook. That's what I said in the review part. Overly technical, a lot of numbers and formulas, which is didn't have to be this way. I'm sure the other way, like simplifying is not easy too, but for me, it didn't do a good job. The difference between significant to not significant is not necessarily significant. I like that. The phrase. So there is between significance to non-significant, which is like, I forgot that percentages exactly. You have this 95%. But the differences between it is not significant, is not necessarily significant, which means that sometimes non-significant could be significant and significant could be non-significant. Media is constantly spinning stories in a negative way. Humans like negative, and the media is definitely doing and contributing to the spinning stories as negative, and using statistics. Oftentimes they use statistics to convey a negative message. So that is for the notes. It's a hard one, but I think eventually I'm gonna give it a 2 because of the accessibility of the book. Even though there is some good ideas, but first of all, there is other good statistics books that did a little better job of conveying ideas. Thank you.